So I finally told you that if v is the velocity, let us say vx I cap plus vy j cap plus vz k cap. If this is the velocity of the molecule, when I write this velocity ranges from 0 to infinity, this v is actually the magnitude of this velocity given by vx square plus vy square plus vz square. And I also told you that this will be an opportunity. You have a system which you want to understand and which is not a very simple system, even though it is simplest of all the systems, but still it is not very simple. You have seen the molecules are moving with jet speeds in random directions, and we want to understand this system consisting of the molecules. And I told you the postulates, I told you the assumptions that we have made, and I told you that even though all of the quantities are equal, there is a distribution of velocity. So that is very, very important point. And I also told you that we will be using statistical averaging, right? We will be using statistical averaging. This I will be using. So like, if you want to understand the overall property of a system, a very important thing is you use statistical averaging, right? Like in a class, suppose there are 100 students and you want to see the performance of the class. So you will take a test and then you will see the average marks. So like अगर principal marks देखना चाहे तो वो एक एक बच्चे के डिटेल में नहीं जाना चाहेगा. प्रिंसिपल देखना चाहे तो वो क्या करेगा कि भाई क्लास 12th की फिजिक्स के एवरेज मार्क्स क्या हैं, उससे पता चल जाएगा कि ओवरऑल क्लास की परफॉर्मेंस क्या है, because he is not interested in the performance of a particular student but the performance of the class, right? So that average tells you everything. Like if we want to see that how our country is doing in terms of economics, we can see average income of a person. We are not interested in income of a particular person, but we will see a data which gives average income of a person. So that will tell you how the country is doing overall. Or there are other parameters, economic parameters. They all are average. Okay. So this is statistical thing is actually, this is also applicable to whole of the finance and economics. So because of the character, because of the very character of this, the statistical mathematics, it is applied to physics also, physical phenomena also, random phenomena, and then the same thing happens with finance, economics, and there also it is applied. Okay. And I want to discuss with you some statistical averaging. First is simply expectation value or average value. Average value or expectation value. Okay. Expectation value. What is this? So this is very simple. I will make a chart. Suppose this is the number of molecules Ni, and this is their suppose velocities Vi, right? So we have N1 number of molecules having V1 velocity, N2 number of molecules having V2, and then some N1, N2, N3 like that. You have different velocities and then you want to calculate the average. So the average of velocity is given by, you will take Ni Vi, right? Ni Vi. So it will be N1 V1 into N2 V2, like that. So average of Vi will be given by summation Ni Vi. I is equal to 1 to N. Suppose there are N distinct entities, or I can write from 1 to G. Suppose there are G different entities, and divided by summation Ni. I is equal to 1 to G, right? So this will give you the average value of a quantity Vi. Same thing can be done in integral also. अभी ये discrete quantity है, तो I am writing it in summation. Same thing can be done with integral also. And this is called expectation value or average value of a quantity, and here that quantity is velocity. If I write the RMS value, this is also a kind of averaging. ये सारी चीजें averaging ही है. So RMS means root mean square. Okay. So read it from this side: square, mean, and then root. So what I have to do is, first of all, I have to take the square of the quantity. Then I have to calculate the mean of the quantity. This will be the symbol of mean. And then I have to calculate the under root, because if you square it, it will change its nature. So finally, I have to take the under root. So these are the steps: square, mean, and then root, and that is called RMS value. So if I say VRMS, it is actually under root of average value of Vi square. Correct? So this will become, you know what is the average value of Vi square? If I write Vi square, so any average will go like this. कोई भी average लिखना है आपको. Average of a quantity will become this. So average of this will become summation I is equal to 1 to G Ni Vi square over summation Ni from I is equal to 1 to G. Please see this. Okay. So this will be the value of this average of Vi square. Then you will take under root of this quantity and you will get VRMS. Right? And third is another quantity which is called most probable. Most probable. So this is clear by the name most probable. So this will be like a quantity which is occurring more times. उस quantity के मिलने की probability ज़्यादा है. So that will be called most probable. So for example, suppose in a class of 10 students, you have taken a test and 4 students got 7 marks, and other 6 student, one student got 10, one student got 9, one student got 1, one student got 2, like that. So 7 is the most probable marks, because if you randomly select one student, then what is the maximum probability of getting a student? Maximum probability will be with mark 7, right?
7.
With mark 7. So that will become most probable. So अगर आप एक probability distribution curve बना लो, suppose this is some distribution curve, I will discuss about it later on. Suppose this is velocity and this is some probability distribution curve represented by some function. So if this is a probability function, the maximum probability suppose is here. So this will become the most probable velocity, because this velocity corresponds to maximum probability. So that's why the name most probable velocity. And in terms of discrete values, I already told you by giving you an example of a class test of 10 marks. And according to that, also you understood what is the most probable velocity. So these are the three expectation values which we generally use in our statistical averaging at most of the time. Even, it will extend to whole of the statistical mechanics also. So this chapter is very, very important for those who want to understand statistical mechanics. क्योंकि कोई एक सिंपल सिस्टम से अगर आप शुरू करते हो तो मैं कुछ भी समझाऊंगा तो आप बार बार वापस इसी सिस्टम पे आके उसको समझ सकते हो. दैट इज द बेस्ट वे टू अंडरस्टैंड कॉम्प्लिकेटेड थिंग्स. इफ यू वांट टू अंडरस्टैंड कॉम्प्लिकेटेड थिंग्स, कीप अ वेरी सिंपल एग्जांपल इन योर माइंड जिसपे बार बार आप जाके उन चीजों को समझ सको. क्योंकि सिंपलेस्ट सिस्टम में भी प्रॉपर्टीज तो सारी की सारी होंगी. यू विल हैव ऑल टाइप ऑफ प्रॉपर्टीज. ओके, तो कॉम्प्लेक्स सिस्टम की अगर कोई कॉम्प्लिकेटेड पैरामीटर है उसको भी सिंपल सिस्टम पे अप्लाई करके समझना इज द बेस्ट पॉलिसी. राइट? सो ये तीनों एवरेज देखो समझ में आ गया. एवरीबॉडी अंडरस्टूड दिस?
Yes, sir.
And there is a need also why we cannot have only average value and why we need other expectation values. So this is also very important question. भाई कोई पूछ सकता है कि when we have expectation value in place, why I need the RMS value? So I will give you a very simple example from electronics to understand this. Suppose I have a voltage V is equal to V naught sine omega t, right? Suppose this is the voltage and I want to calculate the average of V. So that will be given by V naught is constant, average of sine omega t, right? And average of sine omega t is 0. You know that the voltage of sine omega t will go like this, right? So if you take average, ये जितना positive जाएगा उतना ही negative जाएगा in one cycle. So the average will become 0. So this 0 actually kills all the information of the signal. यहाँ पे ना तो तुम किसी से ये बता सकते हो, अगर सपोज कोई पूछे कि तुम्हारे घर में what voltage you are getting, so you will not say कि I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 300, 311, 310, 200, 0, and then negative 311, and then like this. Will you answer like this? No? ऐसे तो आंसर नहीं करोगे ना भाई.
No, sir.
This is the voltage, this is the time. So you will not answer like this. Other way is कि one more example is, suppose you started from place A and you want to go to place B. आपने अपनी जर्नी कर ली. अब किसी ने आपसे पूछा कि भाई what was your speed? So you will not tell it was 0, then it became 1, then it became 40, then it became 100, then again it became 90, then again it became 92. We don't talk like that, na? Because that information is not required, that is useless. So we use average speed, average time taken per kilometer, something like that. Okay. So in the same way, this information is also not required to be told. लेकिन जैसे ही मैं एवरेज लेता हूं इट कम्स आउट टू बी 0. तो हम ये भी नहीं कह सकते कि वी हैव 0 वोल्टेज because information is killed here. So here when you say that my household voltage is 220 volt, it is actually VRMS. ये कौन सा वोल्टेज है? रूट मीन स्क्वायर वोल्टेज है because average voltage is 0. You will not say I have 0 voltage. So what we do is we take the square, it becomes V naught square sine square omega t. As a first step I told you R M S. So first of all we square it, then I will take the mean. average of V square will become average of sine square omega t. And then for VRMS, we will take root of this, which will give me V naught. This average value is actually half. You know this? The average value of sine square omega t will be half. And this will become V naught by under root 2, where V naught is this maximum voltage, right? This is maximum voltage, the amplitude of the voltage, right? So VRMS value is 220 volt. So that's why I was telling you कि जो V वोल्ट है, V नॉट है, वो लगभग 311 वोल्ट हो जाता है. ठीक है? So this is the reason why we always talk in terms of VRMS, not in terms of average value in case of voltage. Absolutely clear to everyone?
Yes, sir.
And
Yes, sir.
if you want to calculate the average value of sine square omega t, you can again take integral sine square omega t, and you can take it as theta if you want to be very, very simple. Omega t is equal to theta. So it will become sine square theta d theta upon integral d theta from 0 to 2 pi, from 0 to 2 pi. This value will come out to be half. You can check this. Simple integration. This value will come out to be half. Even cos square theta will also give half. ठीक है? Average of cos square theta will also be equal to half. Is that fine? So
Yes, sir.
इसमें किसी को कोई doubt है तो पूछ सकते हो. This is how the average thing goes.
No, sir.
No is by default, so you don't need to say no. If you are
Okay.
not speaking, that means. तो
Sir,
इसलिए
average and expectation value are same, na?
yeah, average and expectation is same. So actually these all are different kind of averages, na? All are different kind of averages. But the first one we call average or expectation, the second one we called RMS, and third one we called most probable. But in some sense, all of them are averages, right? Okay. So I hope that this is clear now. So I told you all this because we will be using it. So now next task is to apply what we have learned. We have discussed postulates, we have discussed assumptions. Now your model is ready with certain assumptions. Now let
Sir,
us.
voice break.
Oh, my internet connection is showing unstable.
Once, or it is breaking from my side only. Is it so? हाँ, video lag भी हो रहा है.
Let me
Yes,
check.
sir. वीडियो लैग हो रहा है सर बीच बीच में.
बताना चाहिए था.
आपने last sentence बताया वो सुना ही नहीं दिया सर.
अभी भी हो रहा है क्या?
हाँ,
नहीं
थोड़ा
सर,
सा.
अब सही है.
अभी stable है लेकिन 2 सेकंड before हो रहा था.
एक सेकंड थोड़ा सा देख लेते हैं. अच्छा, लास्ट सेंटेंस क्या था भाई?
सर आप
मॉडलिंग का कुछ बता रहे थे सर आप. मॉडलिंग का.
यस सर.
मैं ये कह रहा था कि जो हमने पोस्टुलेट्स पढ़ लिए और जो हमने assumptions बना लिए, वो सब किस लिए थे? So that we can model the gaseous molecule and we can understand the thermal properties of the gaseous molecule. So now it is time to apply that ऐसे तो मॉडल बनाने का कोई फायदा नहीं है अगर वो किसी पे अप्लाई ना करो और वो एक्सपेरिमेंटल रिजल्ट्स को मैच ना करे. देयर इज नो बेनिफिट. आप समझ पा रहे हो कैसे कनेक्ट हो रही हैं चीजें? सो दिस इज, आई टोल्ड यू दैट दिस इज वन ऑफ द ओकेजन्स जिसमें आप स्क्रैच से कुछ कुछ चीजें डिस्कस कर रहे हो. देन यू विल डेवलप अ मॉडल एंड यू विल रिलेट विद सम एक्सपेरिमेंटल रिजल्ट्स. और ऐसे ही किसी ना किसी कॉम्प्लेक्स सिस्टम की आप मॉडलिंग कर रहे होगे अपने पीएचडी के दौरान. ठीक है. यहाँ पे वो somebody has done long back, but we are trying to just I am trying to recreate it, okay, for you. तो मैं इस तरीके से पढ़ाता हूँ जैसे हमें कुछ अभी पता नहीं है. Starting from scratch, we have assembled the postulates and the ideas given by so many scientists, and slowly we are. Then I told you the statistical things because you know Maxwell, Boltzmann and Clausius also, they introduced the concept of averaging. और उस समय लोगों को बहुत अजीब लग रहा था कि वो चीज जो टॉसिंग ऑफ कॉइन पे अप्लाई हो रही है उसको मॉलिक्यूल के लिए ले जा रहा. सो दैट वाज लुकिंग completely absurd to many people, right? But now in everything we apply probability. Not a single thing, either classical or quantum, is away from the probability, right? So now it is stable, Kanchan?
यस सर, लेकिन वॉइस थोड़ा मेरे साइड से तो ब्रेक हो रहा है.
बाकी लोग बताओ भाई.
आई डोंट नो वेदर इट इज माय नेटवर्क और योर्स. आई थिंक इट इज.
आराम आराम से ही पढ़ना है. ओके. अब देखो, एक मैं बॉक्स ले रहा हूं और इस बॉक्स में I will consider many molecules. Many molecules. Okay. So I will consider a box, and this box will be of length L. It will be having n number of molecules, in it. Okay. And these molecules are in a state of random motion. They will be bombarding the walls of this container, and because of that there will be a pressure on the walls of the container, right? So like आपने अगर observe किया हो तो you have a balloon and suppose we fill air into it. So because of the kinetic energy of the molecules, they bombard on the wall of the balloon and it gets inflated, right? So here the molecules are continuously bombarding the wall of this container, and so there will be a pressure. So I want to calculate the pressure of the gas molecule on the wall of the container, and especially this is a cube, and let us do it for this side. Let us make it coordinate axis. This is suppose x-axis. So what is the perpendicular vector on this wall, the shaded wall? The perpendicular vector on the shaded wall?
X cap.
Very good. So what will be that? It will be x cap, right? On this. And pressure, you know, is a vector quantity. But because we fix the direction of the force, it becomes a scalar quantity. Because vector ka sirf differentiating factor direction hai. Once you fix the direction, there is no need to consider it to be a vector quantity. So why is the pressure scalar? Because you have F perpendicular over area, right? This is correct?
Yes, sir.
The definition of pressure is F perpendicular over area, and F perpendicular means perpendicular force to the area. So I will be only considering the force which is perpendicular to this wall. And what will be that force? Somebody will tell me. What will be that force? It will be Fx, right?
Yes, sir.
Because only X component of force I
Yes.
need. So this is the thing that I wanted to tell you in advance. The definition of pressure is very, very important. Now, please understand that the molecules, they are distributed like this. So their speeds are, there is a distribution of speed. So ऐसा हो सकता है कि this is 100 meter per second and this is 2000 meter per second and this is 110 meter per second. This is 300 meter per second. This is 400 meter per second. This is 500 meter per second. This is 450 meter per second, like that. There is complete distribution of molecule. So in terms of velocity, can I say that at this place velocity will be more and at this place velocity will be less? Can I say that?
No, sir.
No. If you hold a chunk of molecules, they will have all kind of speeds, right? There is
Right,
no
sir.
reason why
So,
certain section will have the molecules with greater speed. So it will be fully isotropic, fully uniform velocity, right? By uniformity, I mean कि हर type की velocity हर जगह present होगी. There will be a velocity distribution. So
Yes.
what I am trying to do is I will put this
so
in groups. Yes.
will
Yes.
you please repeat the last statement, because I think I'm facing some issue. There is a isotropic medium. Will you please repeat that
That was the
statement?
last sentence actually. I just told
But
that
the
all
reason,
type of velocities will be present everywhere. All type of velocities will be present everywhere. And if you see some small chunk of volume, that will be having molecules with all type of velocities. Because there is no reason to have a particular type of velocity at a particular place, right?
no.
We have not done
Yes.
anything. So that's why. So depending on the velocities, I can put the molecules into groups. So groups का division मैं किस basis पे कर रहा हूँ? जैसे कि मान लो मेरे क्लास में 100 बच्चे हों और मैं उनका टेस्ट ले लूं, और टेस्ट में ऐसा हो सकता है ना कि मान लो टेस्ट में 100 मार्क्स का टेस्ट है, ओके, एंड इज दिस पॉसिबल कि 10 नंबर 10 बच्चे पाए? ट्वेंटी मार्क्स 5 स्टूडेंट्स को मिले, इज इट पॉसिबल?
हाँ सर, बहुत टफ पेपर है.
30 मार्क्स 15 स्टूडेंट्स को मिले, इस तरीके का मैं डिस्ट्रीब्यूशन कर सकता हूँ.
Yes, sir.
सो मैं इसको एक ग्रुप भी तो बना सकता हूँ, 10 मार्क्स वाला ग्रुप,
Yes, sir.
20 मार्क्स वाला ग्रुप, 30 मार्क्स वाला ग्रुप, and then these are the number of students. So similarly, I can make the group on the basis of fill in the blanks.
Velocity.
Very good.
Velocity.
On the basis of velocity. ठीक है ना?
Yes, sir.
So मैंने ग्रुप बना दिए on the basis of velocity. So इस तरीके से लिखूंगा कि suppose ni number of particles are present with velocity vi in group I. Is that okay?
Yes, sir.
And I will run from, let's suppose there are G groups. There are G groups. So I will run from 1 to
G.
सारे G ग्रुप्स हो जाएंगे? तो जरा लिख के बताओ कि कैसा टेबल बनेगा यहाँ पे. क्विकली गाइड मी.
N1 V1
V1
N1 वाले V1,
N2 V2 dot dot
N2
dot
V2
N2 वाले
VG.
V2, very good. NG,
NG VG.
NGVG.
very good. And here I can write NIVI, right?
Yes, sir.
Yes, sir.
So this is the chart having different kind of velocities. Am I right?
Yes,
अब
sir.
देखो statistical calculation का फायदा क्या है? You don't need to do calculation for each and everything. You just pick up this, do the calculation, and then generalize it, right? Are you getting my point? So you take this, do all the calculation, then you can like suppose you want to get election से पहले वाला एग्जिट पोल. सो आपने पॉकेट्स बना लिए पूरे इंडिया में. अब हर पॉकेट का डेटा आपके पास आ गया, तो एक पॉकेट पे स्टैटिस्टिकल कैलकुलेशन करो, वही स्टैटिस्टिकल कैलकुलेशन सारे पॉकेट्स पे कर दो. यू आर डन. यस और नो? So that's why, you know, the coding becomes so powerful that you have to just apply things on one section and then you can apply it for millions of the section, right? So I will understand this. So मैं उन molecules को ढूंढ रहा हूं जिनकी velocity v1 है. वो कहां मिलेगा भाई, बताओ जरा.
पूरे वॉल्यूम में
यहाँ पे मिलेगा या यहाँ मिलेगा, यहाँ मिलेगा, या फिर
टोटल
ओरिजिन के पास होगा.
टोटल वॉल्यूम
कहीं पे मिल सकता है,
कहीं पे भी हो सकता है. और उसका नंबर कितना है? n1.
N1.
और ये चलो मैं इस n1 में से मैं एक मॉलिक्यूल को पकड़ लिया मैंने, ये यहाँ पे है. ओके, दिस इज द मॉलिक्यूल हैविंग वेलोसिटी v1. प्लीज सी दिस. This is having velocity v1. Velocity is a vector quantity. Am I right? So this velocity which is moving towards this shaded will be given by, so I have selected n1 number of particles having velocity v1, but I will only see v1x. Why? Please off your mic. जब भी on करो off कर दिया करो भाई.
प्रेशर उसी दिशा में निकालना.
Why I want v1x? Because I want to see the pressure on the shaded portion. And what is the perpendicular force that I am going to get? Yes.
F1x.
That will be perpendicular to this. So that will I will be getting from the perpendicular velocity, right?
Yes, sir.
So that will become v1x. So देख लो पहले. G groups से फर्स्ट ग्रुप पे आ गए. फर्स्ट ग्रुप की वेलोसिटी v1 है. v1 में भी सारे कंपोनेंट देखने की जरूरत नहीं है, जस्ट आपको क्या कंपोनेंट देखने की जरूरत है? विच कंपोनेंट यू वांट टू सी? ओनली x कंपोनेंट. इज दैट ओके? So
Yes,
now
Yes,
if
sir.
you see the momentum of this p1x, it will be equal to mv1x. Am I right? It will be moving with this momentum. It will collide and then come back. So after collision, what will be the change in momentum?
2 times mv.
Let us write delta p1x. It will be equal to 2 times m v1x. So you can do the calculation by putting m v1x minus times m v1x. This will give you this 2 times m v1x. Is that correct?
Yeah.
And the force that is generating is because of the bombardment of the molecules. I told you the molecules will hit it and then go back, and again it will come and hit it. So what will be the time taken? Time taken for that? It will cover distance 2l. So distance upon time upon velocity, which is v1x. This will be the time scale. So you have now force because of one molecule. You have force, and that force I am writing it as F1x. Is that okay? F1x. That will be equal to, bolo bhai, 2m v1x upon 2l by v1x, which is equal to 2 and 2 will get cancelled. It will become m
V1
v1x square over L.
L.
So this is the force due to one molecule from the group 1. This is the group 1, right? If I put group also here, this is the group 1 and this is the group G. Is that okay or not? Yeah?
Yes, sir.
So ये पहले वाले ग्रुप के पहले मॉलिक्यूल की वजह से टक्कर जो हुई उसकी वजह से ये फोर्स निकल आया. बट इस ग्रुप में टोटल कितने मॉलिक्यूल्स हैं जिनकी वेलोसिटी v1 है?
N1.
N1. So let me say due to N1 molecules, the force 1x will be equal to, so मैंने ये 1 जो है ये पहले ग्रुप को रिप्रेजेंट करता है. So the force will be equal to m n1 v1x square by L. Is that okay? Yes?
Yes, sir.
और अब मैं यहां तक कोई डाउट हो तो
सर ये 1x वेलोसिटी है ना शेडेड रीजन पर.
सॉरी,
तो v1x वेलोसिटी है ना शेडेड रीजन पर.
v1x क्या है?
वेलोसिटी ऑन शेडेड रीजन.
I think you are not getting the point. What is v1? Anybody can tell?
The velocity of
ये कोई भी एक बताओ भाई. चलो
Group
कौन?
velocity of one molecule belonging to N1 group. First group, sir.
So there are how many number of groups?
The G.
जिन्होंने पूछा है. What is your name?
नेहा सर.
Neha. What is the number of groups in which I have divided? The total number of molecules. कितने ग्रुप में डिवाइड किए हैं?
सर जी ग्रुप.
G ग्रुप में डिवाइड किए हैं. पहला ग्रुप में कितने मॉलिक्यूल हैं?
N1
उनकी वेलोसिटी क्या है?
v1
v1. तो v1 क्या है? अब बताओ.
वेलोसिटी. सर आई एम आस्किंग अबाउट v1x.
पहले v1 बताओगे तब v1x समझना आसान होगा ना. So v1 is the velocity from the first group. A molecule selected from the first group is having velocity v1 and v1x is the x component of that velocity.
Okay sir.
v1x is the x component. Why I have taken x component, Neha?
Because it is in the x direction.
Why I am interested in x component of the velocity? My question is that.
Pressure x बोलते हैं ना.
Because the definition of pressure is force perpendicular.
Perpendicular,
So
yes.
I am just seeing the perpendicular, right? But I am interested in pressure. So pressure on this wall I am going to calculate, right? Pressure on
Yes,
this
sir.
wall. So pressure on this wall P1 is equal to force over area. Is this okay? P1 is okay? बोलो भाई जल्दी जल्दी. P1 is okay?
Yes, sir.
Yes sir.
So do I need to write P1x? No.
No, sir.
Because जो प्रेशर यहां निकल रहा है that is by definition perpendicular force was required और मैंने perpendicular force ले लिया. But that pressure is because of N1 molecules. So that's why this is appearing. But similarly, overall pressure on this shaded region, shaded side will be because of all groups. Do you agree or not? ऐसा तो है नहीं कि पहले ग्रुप का मॉलिक्यूल इधर भाग रहा है और बाकी सारे आराम कर रहे हैं. क्यों भाई? So the pressure will be because of all groups. So I should sum them up. अब देखो कैसे statistical काम करता है कि you have done it for 1, Now you have extended the idea to all. अब ये छोटी छोटी चीजें सीखने वाली हैं, वैसे रट्टा मारोगे तो फायदा नहीं है, but अगर understand करोगे तो it will be very very helpful. So this will be equal to, tell me, P is, and can I write P this pressure? Because if you hit the wall, Y wall, same pressure. This wall, same pressure. This wall, same pressure. So that's why I have, once I have added it, I have written it P. Is that okay, भाई? सबको?
Yes, sir.
ये
Yes,
बात
sir.
जरा सोचना, ये सब postulates use हो रहे हैं फटाफट. So because of the system being similar, if I get the pressure on this wall, similar pressure will be on the all 6 walls of this cube. So that's why I have now generalized it, that I have written it P, and I have taken care of all the groups. So this will become, देखो जरा, now N1, N2, N3, and ये क्या बनता जाएगा? V1, V2, V3. So it will become M by L cube summation I is equal to 1 to G Ni VIX squared, like this. Is that okay?
Yes, sir.
So ये भी एक JEST का previous year question है to this level. If there are G groups, what is the pressure that this wall will be feeling in terms of X component? So this is the pressure that wall will be feeling in terms of X component. And now you can see, I will run from 1 to G, pehla group, dusra group, tisra group, chautha group. So it will be running like this, and you will get the pressure like this. Okay? Yes?
Yes, sir.
Now, what about this? I have told you that if you want to calculate average of, say, VIX square, what you will do? You will write summation, can you tell me? Ni VIX square over summation Ni. Am I right?
Yes, sir.
I equal to 1 to G.
Right?
Yes, sir.
So I can just write this as P is equal to M by L cube. And for this, what I can write? You see this. ये किसके equal है? VRMS? Right?
Yes, sir.
But this is VRMS square, na? VRMS square. So I can write VRMS X square and multiplied by N, right? Multiplied by N.
Yes, sir.
Because summation Ni is N, right? Now, if you write VRMS square, you can write Vx, this component, plus Y plus Z, RMS, RMS, RMS. And since the RMS value, because of the isotropic system, it can be considered same, because there is no reason कि Y वाला component का RMS ज़्यादा हो X वाले component से. So you can write it as VRMS square is equal to 3 Vx comma RMS square. So this will be replaced by 1 by 3 VRMS square. Please see this. So this will become P is equal to Mn by L cube into 1 by 3 V RMS square. So X component, Y component, Z component is gone. Now you have overall VRMS. And this is number of molecules per unit volume. So this will be given by P is equal to 1 by 3 Mn into VRMS square. So this is the pressure that you have got, where N is number density. It is number of molecules per unit volume. So see, this has gone in per unit volume. So does not matter, for cube is gone. because per unit volume has come. पर यूनिट वॉल्यूम आ गया तो चाहे तुम यही प्रेशर का फॉर्मूला बाहर एटमॉस्फेयर में लगा दो, चाहे घर के अंदर लगा दो, पर यूनिट वॉल्यूम हो चुका है. that quantity is gone, right? So this is the pressure that you have calculated from your model, and you can see this pressure is because of kinetic energy. Vrms square is coming, which is the velocity thing. So that's why it is Vrms square, and that's why it is something mechanics. So you can see mechanics and pressure, they are related here. यहाँ तक कोई डाउट हो तो बताओ.
सर ये VRMS स्क्वायर इज इक्वल्स टू ये 3 VRMS स्क्वायर इस आया क्योंकि these three are same.
हाँ, because x के about RMS, y के about RMS, z के about RMS, तीनों के अलग होने की कोई वजह नहीं है. एवरेज वैल्यूज है ना.
यस सर, यस
तो
सर.
ऐसा तो है नहीं कि x की तरफ ज्यादा वेलोसिटी आ रही होगी, y की तरफ कम और z की तरफ कम ना.
ओके सर.
तो इसलिए ये अप्रोक्सीमेशन कर लिया.
ओके सर, थैंक यू सर.
तो सारे पोस्टुलेट्स का आपने यूज देख रहे हो कैसे किया. वेलोसिटी अलग अलग कर ली बिकॉज वेलोसिटी डिस्ट्रीब्यूशन है. देन प्रेशर का डेफिनेशन लगा लिया. देन मोमेंटम, चेंज इन मोमेंटम, न्यूटोनियन मैकेनिक्स वी प्रॉमिस्ड दैट वी विल अप्लाई, एंड देन मैथमेटिकल स्टैटिस्टिक्स आई टोल्ड यू दैट आई हैव अप्लाइड, एंड आई गॉट द फॉर्मूला फॉर प्रेशर. और ये मत कंफ्यूज होना, स्मॉल n इज हियर, नंबर डेंसिटी कैपिटल N ओवर V, राइट. अब इमीडिएटली you can connect it with, आपने क्या कहा था, the molecular motion is responsible for the energy, thermal energy. So we can immediately see that pressure is equal to 2/3 N into, please see this, kinetic energy. Can you see this?
Yes, sir.
Yes, sir.
Because मैंने 2 से मल्टीप्लाई और डिवाइड कर दिया तो प्रेशर ये आ गया, और n को n/v लिख दो, n/v. So PV will become 2/3 and n times kinetic energy. This is kinetic energy of one molecule, and n. So you can see that pressure and kinetic energies are related. And if you write PV is equal to nRT, पता है ना? PV is equal to nRT, the ideal gas equation. So you can immediately write 2/3 n times kinetic energy is equal to this n. ये सब n अलग अलग हैं, इसको म्यू लिख देता हूं so that you will not confuse. This is number of moles, which is n/Na, right? And this is R, this is T. So now n will cancel, and your kinetic energy of a molecule, of a single molecule, R/Na. R is universal gas constant, Na is Avogadro number. So this will become 3/2 kBT. This is not a small thing. जब पहली बार देखा लोगों ने तो they got shocked कि भाई जो टेम्परेचर है that is just clearly related to the mechanical kinetic energy. It is proportional to mechanical kinetic energy. So temperature is just mechanical interpretation, nothing else. And Kb is the Boltzmann constant, having the value 1.38 into 10 to the power
-23.
-23, right? 1.38 into 10 to the power -23 in SI unit. So it will become joule per Kelvin. So this is known as kinetic interpretation of temperature. Temperature is just a signal of what is happening with the molecules. So आपकी body में blood molecules dance कर रहे हैं, और उसका simple signal तुम्हारे temperature में show होता है. Temperature is more, इसका मतलब molecules ज्यादा dance कर रहे हैं. Temperature is normal, that means they are normally dancing. And you can also see that this molecule will never stop. Molecule will never stop. So T will never go to 0. So never, kinetic energy will never become 0. So molecule will temperature will also never become 0. So all that aspect I will discuss in next class. If you have any doubt, you can ask. Otherwise, I will stop here.
Good evening, sir.
Good evening.
Sir, here you said PV is equals to mu RT. It is
Yeah.
applicable for real gases only. Sorry, ideal gases only.
Yeah. We are just discussing the ideal gas right now. Because
Okay,
we
so-
have taken everything ideal, zero size, point size of the molecule, zero interaction, no interaction among the molecule, right?
Okay, sir.
Your molecule is perfectly elastic, the change in momentum, right? So
Sir,
everything is
blood molecules हम real मानेंगे या फिर ideal मानेंगे?
वो तो बहुत ही कॉम्प्लेक्स रियल सिचुएशन, वो तो गैस मॉलिक्यूल होगा भी नहीं ना, दैट इज लिक्विड, बट स्टिल द आइडियाज गो सेम. ऐसा नहीं है कि वहां पे मॉलिक्यूलर मोशन को टेम्परेचर इंटरप्रेट नहीं कर रहा है. भाई आप चाय को देखो ना, चाय को खौलाना शुरू करते हो तो मॉलिक्यूल डांस करना शुरू कर देता है ना.
यस सर.
तो टेम्परेचर एंड काइनेटिक एनर्जी दे आर रिलेटेड. ओके
ओके.
So that idea will go everywhere. उसी को तो ज्यादा रिफाइन करते करते आज हम इतने अच्छे मॉडल्स बना पा रहे हैं ना. But starting is this. This is the starting point, right?
Okay.
Yeah. Anybody else wants to ask anything? Okay. Thank you. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.